Okay, hello, good afternoon. Welcome to your last session of the day. And welcome to the session with officially the longest title of Build this year. I'm Jeroen Teheert. I work as a program manager in the Azure data team focusing on SQL big data clusters. And with me today is Anna.
Yeah, I'm Anna Thomas. I'm a data and applied scientist on the SQL team as well. And before we get started, we just like to do a little poll to see who's in the room, if you guys want to see the code that we could show you, or that sort of thing. So just a few quick polls, because we do cover a lot of different tech here. If you consider yourself like a DBA, could you raise your hand? No DBAs?
No DBAs,
okay.
Some...
Maybe kind of?
Previous slide. Okay, makes sense.
That's fair. Okay, and then I'm guessing most of you are developers? Kind of, okay. If your primary language to develop is .NET, Python, R,
and then
Java.
1.
Okay.
2.
So we're going to talk about Java a decent bit, but we'll make sure we make it relevant to other languages as well. And then if you're familiar with big data clusters, if you've heard of them before, a few, and containers. Okay, that's good. We'll skip that part.
Cool. Yeah, let's dive right in. We have a lot to cover. So yeah, this is the agenda. We'll talk about the big data landscape. We'll talk about big data clusters. We'll talk about SQL Server extensibility. We'll do some demos. We'll walk through a scenario on a customer case, and we'll talk about data ops. And I'll leave that to later to explain what that is. So that's basically what we'll be covering here today. And we need to talk about this number. That's the number 35. Unfortunately, it's not 42, but it's the amount of data that people generate. It's the amount of data that we generate in 1 year. We actually generate the same amount of data in 24 hours now as we did in the same period from the Big Bang Theory to 1980. So that time span we now do in 24 hours. So it's a potential of a lot of data to be analyzed. So 35 zettabytes is the amount of data that we generate as people in a year. So if that boggles your mind, here's some math that I use to understand all of this. So 35 zettabytes is actually 35 times 10 to the power of 21, which is the sum of all the sand particles of all the beaches in the world times 5. So imagine you could have a big box with all the sand particles of all the beaches in the world. You do that 5 times, you get the amount of data that we generate. And that's pretty impressive, I would say. And it helps us potentially to become better companies or better persons or whatever you want to be, better organizations. But are we really getting the benefit out of that today? I don't think so. And people tend to use a certain technology for this, and we need to talk about it, right? Let's talk about this elephant in the room. You recognize this guy, right? So this data happened, all the data is out there, and the people said we need technology to analyze all that data. So they all went to Hadoop. Cool. But how many of those Hadoop projects were actually very successful? And how many happened in time and on budget? And how many were actually implemented so that business users could use it? None. Almost none. So even if you were successful to deploy Hadoop, and one does not simply deploy Hadoop, right? It's not easy. Even if you were successful, your business users would feel lost. And you end up with this situation where people were drowning in a lake of data while they're breathless for insight. And yes, this is a very dark sentiment. But I feel this is the truth. And I feel as an organization, as an industry, as a group of people coming together around a certain platform, we can do better. We can do better than leaving our business users and our developers and our IT folk drowning in a lake of data. And that's where one of the reasons for us to come up with SQL Server Big Data Clusters. So one of the things that we're doing with SQL Server Big Data Clusters, we're trying to bridge the structured world, SQL, which we all know and love, hopefully, with the big data world, where the semi-structured data is, where your Hadoop system lives. And the whole thinking here is, should your user really care where the data is stored? And should you manage all the data in separate systems? Or should you have one layer that allows you to query the data regardless of where the data sits in your environment. So you have data sprawl everywhere. You have data in your Hadoop cluster, in SQL, in Oracle, you name it, right? But in the end, what your business application user or your developer or your data scientist wants to do is just use the data, get some value out of it. They shouldn't bother about, oh, wait, now I need to go to this BRK file somewhere and query it and ingest it, and then, it doesn't work. So big data cluster is here to help, and of course we're doing more stuff, we'll talk about it, but that's kind of the central premise here. So let's think about a customer. It's White World Importers, that's our traditional brick and mortar store. We'll be using this as a sample as we go through this session. White World Importers, as I said, is a brick and mortar business. They transformed into an omni-channel strategy with retail, web, and mobile, the typical things that we see customers do these days, right? They sell, I think they are into the decoration and stuff like that, right?
Decorations, they do a lot of importing all over the world. They're retail, shipping.
Yeah, so retail, shipping is a big part. We'll actually look into that scenario a little later on. So yeah, they feel they need technology and changes to handle all the data that all those channels generate. So they're feeling this pain. They're generating a lot of data, but they don't feel they get the most out of the data. So their challenges here are to scale the data systems, to reach more customers, to be profitable, to get more insights out of the data that they collect, to start applying deep analytics and AI, and infuse that AI into applications. So that's kind of the scenario we're looking for. And in this session, we'll go through each of these and see how they can implement some of these challenges and solve some of these challenges using BDC and all the good stuff that we'll show in a second. So keep that in mind.
Yeah, and if you hear us say BDC, we're saying big data clusters.
Yes, absolutely.
It's a lot of syllables to say SQL Server, big data clusters.
Yep. BDC is Microsoft speak for big data clusters. Yep, good one. So yeah, SQL Server, BDC, or SQL Server in general, simplifies big data deployment, operation, and integration. So we're trying to make it simple for you to, first of all, deploy a cluster that can handle any data you throw at it, that can integrate with whatever you already have there today and operate all of that and manage that in a simplified fashion. With SQL Server, big data clusters, we're marrying, as I said, the structured and the semi-structured world. As you can see here on this picture, the two icons that are clearly in love, the database and the semi-structured world come together into one happy cluster, and it's all built on Kubernetes. So it's all containerized, it's all flexible and scalable in that way. It has Hadoop integrated if you want to. You can also link it to external Hadoop if you already have the Hadoop environment, HDFS environment sitting there. You can integrate with that. And then we bring you HDFS, as I said, Hadoop file system, SQL Server, and we bring you the Spark engine as containers inside of this cluster. So here's some more details about it. Basically, we build upon Kubernetes, as I said, so that's what you start with. A couple of nodes with Kubernetes on it, and in there you're going to deploy the big data cluster that has Spark, SQL, HDFS, and the way your developers, your BI analysts, your data scientists, you as a developer talk to it, you talk to the master instance, and you get access to all the data that the cluster knows of. And the data might sit inside of the cluster, might sit outside of the cluster. So through data virtualization, we can also link to external data sources that are not inside of the cluster. So you already have an Hadoop installation, we link to it. You already have an Oracle database sitting somewhere, we connect to it and we virtualize over it and allow you to query all of that as if it was part of the cluster.
Yeah, and I think if I could add one thing is that at the end of the day, this seems very complicated and is complicated, but from a user's perspective, you're really just interacting with that master instance, as Jeroen said. So it's just SQL, right? That's what you see, whether you're reaching out to some other data source or you're reaching down to Hadoop, all you have to interact with is SQL.
Yeah, absolutely. So if you start looking at how that would work in a analysis scenario, this is kind of the typical steps that people go through. You have your data source on the left side. You have to ingest the data there. Ingesting meaning getting access to the data, cleaning it, analyzing it, doing some manipulation maybe on it, and then later you need to store it. So either you virtualize it or you store it in an actual store, which could be Hadoop or a database like SQL Server. And then the good stuff starts, because that's where you want to start training and learning a machine learning model to predict something. So you could, for example, be using Spark or R or Python, whatever you want to do. And then when you have a cool predictive model built, you want to deploy that, right? So a model in itself is not very useful to your business user, right? They won't understand that pickle file that you just sent them if you're using Python. They won't be able to use that for their business decisions. So you need to model that somehow and serve it into a scoring model and expose that scoring model in for example, a RESTful API. And then that RESTful API can be integrated in your web app, in your mobile app, or whatever business app you have. So those are kind of the generic steps that people follow. So White World Importers does kind of the same thing, right? They have log files from their shipping, right? That is structured or semi-structured. It's ingested into the cluster, it's stored on HDFS, and then the data is trained upon and used to analyze what is inside of those shipping instructions and be able to understand, hey, where does this package need to go? From where to where, when? So we're analyzing that semi-structured data, using this cluster into and exposing that as an API for our application to use. So that's how White World Importers uses this platform to solve that challenge. So then, last thing, I think, before we jump to White World Importers again, this Big Data Clusters has a notebook experience integrated. So if you like notebooks, if you run those, you can choose R, PySpark, Python, and even T-SQL to run as part of notebooks. So notebooks are a generic and integrated element of this platform. And it makes it very easy to run any ML workflows and also to deploy apps, including ML models, to the cluster, and we'll see that in a sec. So yeah, just to summarize White World Importers, their challenges: scaling of the data systems, unlocking business insights, enabling and applying deep analytics, and enabling AI infusion into their apps. As you can see, the big data clusters allow you to scale those data systems to a bigger scale. It allows you to do more integrated business insight, and it allows you to get high performance responses on that analytics that you run inside the cluster, because, well, it's a cluster, so it's scalable. So with that, let's see how we can apply that.
Thanks. So we talked a little bit about big data clusters, and it seems like a lot of you have heard of them before, so maybe that's not such an overwhelming topic for today. We're going to talk also about SQL ML services. Most of you have heard of that? Yes, no? Yes? Actually, I said yes and no and raise your hand. That's not helpful. So let's take a step back and talk about what that is, and then we'll kind of work towards how it relates to big data clusters. So we have this idea of in-database machine learning, and you may have heard of it before, but let's look at how it's typically done, just in general, machine learning. So you have your application, and you're storing your data somewhere. In this case, you're storing it in a SQL database, right? Now, in order to do your analytics or your training or your transformations, you're going to move it into an analytical server, right, or your analytics server. And from there, you'll get a model, your trained model for whatever it is you're trying to predict. And you'll deploy that as some sort of scoring logic or embedded service. Now, when you get new transactions from your application, they route to that scoring service and then send those predictions back. And what you might notice here by all those lines is that we're moving the data a lot. And there are a lot of costs to doing this. There's latency implications. There's data fidelity implications there. So really, if we could not do that, that would be ideal. So with in-database machine learning, we can basically take our data from our application, our transactions or whatever it is, and do all of the things we were trying to do in different places in one place. And so that's what we tried to do with SQL ML services. Now, a brief history lesson, and then predictions go back. A brief history lesson on how we got to where we are today is in 2015, we acquired a company called Revolution Analytics. You may have heard of them. And fun fact, half of that team was my old team on AI platform, and the other half came over to the SQL team. And what they did is they renamed our server to ML Server, because at Microsoft we rename things because it's not enough to have a lot of products, but you have to keep changing the names, right?
Of course, it keeps you on your toes.
Keeping us all on our toes. But we said, oh, this is pretty cool. What if we could do this inside of all those SQL servers we already have all over the place? And so we came out with SQL Server ML services for R. And I'll show you how this all works, but just the basics. But we came out with R, and people said, oh, this is cool, but actually I like Python, I like scikit-learn, and so why don't you guys support Python? So we quickly followed with Python, and so now we're supporting a good chunk of data scientists. And in 2019, we said, well, we did all this work to support R and Python. What about things that are just easier to do in other languages? So we came out with an extensibility type of framework, and in 2019 specifically, we're announcing Java. So how this works, and some of you may have seen this before, is that through a stored procedure, you're able to access the data in SQL Server, and what it does is it actually uses what we call Launchpad to launch these satellite programs, satellite R, or Python, or Java. And the nice thing about this is that you see it's running outside of SQL Server. So it's not running in the OS or in the engine. It's actually using a different line of communication to get the data. What this means is if my Java program blows up, it's not going to blow up my SQL Server. So with Java specifically, you can see this stored procedure is how you would call out what you're trying to do. I can't easily laser to both of these. But what you see is you see the language is Java. If you were doing Python or R, you would do that, put that there, and then you put your script. And for R or Python, you actually can put your code right there, importing the libraries that you need. With Java, you put the class that you want to use. So you use your compiled jar files, and I know we don't have a lot of Java developers in the room, but basically you compile that program and you point to it. And what I want to call out too as well is that this says SQL Server 2019, but in big data clusters, it's the master instance. So all of these capabilities are baked into the main part of BDC. So again, as a user, when you're interacting and trying to add this to your applications, it's just SQL. It's the same. So if we take it back to wide world importers, Jaron already talked about how we're supporting some of the challenges that wide world importers and many retailers and customers are facing, but I want to focus on the enabling AI. There's a lot of directions we could go with this, but we're going to focus on enabling AI. So we talked to wide world importers, and they said, we want a medium box of AI. Like, take our data, give us some AI. And that's what customers do a lot, and sometimes you have to work through explaining what that means. But in this case, we looked through their tables and their databases, and we came across these delivery notes. So you'll notice. Sorry. Jaron spent a lot of time on these animations.
Yeah, I did.
He's very proud of them.
Yes.
But basically, we found that the drivers of these trucks are leaving notes that are coming into the database, but as you can see, they're not really in a format that SQL Server can pick out, where they're going, where they're coming from, or when they're arriving. And they're using different formats, like they're abbreviating the days of the weeks. They're saying times is noon. They're saying next or this Friday. And so there's not really an easy way to get that info out. And looking around, looking at all the things you've seen through Siri, Cortana, Alexa, you're like, there's got to be something I could do here. But I'm not a data scientist, but I want to get that information out. And there's not an easy way to do that with T-SQL. And so that's where cognitive services comes into the mix. And many of you have probably seen some of them throughout the conference this week. But basically, this is a set of APIs, some are customizable, that you can use to basically leverage Microsoft research, their research that they've been doing for the past 25 years. So they've packaged up some of their really great models and put them into APIs. So you see there are different kind of classes, and I definitely recommend checking out the directory. They've got a bunch of cool little samples just right on the browser. But looking at this, we said, okay, so we're probably looking at the language space, and is there something we could use here? And there's actually a cognitive service called LUIS. Now I think it's just the language understanding service, but it used to be LUIS, and we still all refer to it as LUIS. But what LUIS does is it's one of the more custom cognitive services. So what that means is I'm actually able to use a GUI or REST APIs and train on top of a base layer model for language understanding to my specific use case. And I'll show you just a brief of what I did. But basically, this makes it very easy. I was able to create a model to pull out the origin and the destination and the date time in less than an hour. So if we take a look at this architecture, what's happening is I built a Java program. It's called LUIS.jar. You see it there. And what it does is it calls that cognitive service API, specifically the model that I created up in Azure. It sends the data for each row up to Azure, returns the results, and then that Java program parses out, I want the origin to go in this column, destination in this column, and date time in this column. And then it's using the data from our SQL Server master instance in our big data cluster, and we can see the results from that. So let's check it out after I log in. OK.
Let's see.
Cool. So I won't spend time going through how I created this model, but this is LUIS. It's really cool. It's really easy. You can see I basically typed in some sample things they might say, and eventually it learned that this was the destination, this is the origin, and this is the date time. It uses the context of the other words to create a model. It was very easy for me to do. So what I was able to do in SQL is then build that into a Java program. So you can see, and I'm not going to go through the code, but you can see I'm calling out to the central US cognitive service, and this application returns, it takes in something like deliver to Atlanta from Los Angeles Tuesday at 4 p.m. and picks out the origin, the destination, and the date time. So now I compile this Java program, and I move it into the big data cluster. And so let's take a look at that. Let's see. Another quick overview. This is Azure Data Studio. If you haven't played with it before, I highly recommend it. This specifically is the notebook feature, which allows me to play with text and code in the same file. And here we're actually using a SQL kernel. You can see there's other kernels available, but the SQL kernel is only available in Azure Data Studio right now. Eventually, it'll go out to Jupyter Notebooks, if you're familiar. But right now, it's only in Azure Data Studio. You can also see I'm connecting to my Azure, my Anna Big Data. See, very creative of myself. But you can see in here the different databases that I have and some other information that I can do within the big data cluster through Azure Data Studio. But if I go back to that notebook, the first thing I have to do is enable external scripts. And what this allows is basically allows me to use the ML services or Java extensibility. I'll also specify the database I want to use, and then I'll create an external library reference to the SDK. And this SDK makes it easier for me to develop Java apps that work with SQL. And it's just saying I already have it. So again, we can look at those deliveries, and I just pulled this one column. There are many more columns. And I can create an external library, if I can scroll, to that LUIS jar file that I created, so basically the compiled Java program. And then I can go ahead and use the sp execute external script. So I'm specifying the language, I'm specifying the class within my package for LUIS, and then I'm just selecting a few to query and return the results. And you can see I want to return the ID, the instructions, the origin, destination, and the delivery date time. So you can see it's done that. It's gone out and it's gone out with the data to Azure, brought the results back, and put them into column. So now I could actually do something with this, right? I could apply some analytics, see how long it's taking people to get from A to B, where people are going, where people are coming from, this sort of thing. So that's pretty cool, but does anyone see any potential issues with this? Again, I'm sending that data out to Azure, waiting for the results, and then processing. Latency. Latency is a huge issue here, right? There, you saw how long it took, and I was only doing 10 answers rows. Because we're making 10 calls out to Azure.
So how many rows does whiteboard importers have?
A lot more than 10.
Okay.
Does anyone see any other issues? And this would depend on the customer or the business or the company.
Right. Security?
Security, right.
What type of security? What? Yeah, what are you thinking? Yeah. Potentially customer information, PII, maybe, yeah. Deliver this to Mrs. Robinson in Atlanta, who lives at blah, blah, blah address, right? Yeah.
Like maybe data sovereignty, like basically the same reason that you don't want to put your data outside the order.
Yep. Yeah, so if you're in certain industries or you're dealing with, okay, there you go. Could have guessed then. So yeah, if you're dealing with certain industries or certain financial information, if you're not even in the financial industry, but you know, you don't want to send the data to the cloud. Yep. Sorry, I didn't get that. Sure, so you're saying accessing local resources with elevated permissions, and you don't want to do that in a situation where you're talking to the cloud, right?
Right, because your external have to be somewhere on your system or
right.
You know, a network location.
Sure.
Stuff like that. And
yep.
Now your SQL Server would have to have permission to access those permissions,
right? Right, but the jar file can sit on the SQL Server itself, right? So it's right, still there. Yeah, true. Yep. So. Okay, let's take that offline. I would like to understand a little bit more where you're coming from there. Okay, cool. So yeah. Let's see. Yeah, so essentially the things that we thought of is what if you don't want to, you're not allowed to, or you cannot use the public cloud, right? And this is the only meme that we were allowed to keep. Inside of our presentation, we had like 5 or 6 memes. We had to pull them all out. But anyway, this is the only meme that survived. But seriously, this is, you know, we can talk about the cloud all day long, but there's so many scenarios where you cannot, will not, are not allowed to, or you cannot, you know, you cannot do the cloud for whatever reason, right? Latency, security, things you don't trust. So you need a solution there. You need a solution that helps you get the best out of the cloud, but then on your terms. And then the SQL Server Big Data Clusters is already a good step in the right direction because it's a flexible platform, it's containerized, so it's, you know, cloud-like behavior with scalability on your own terms. We can do a little bit better than that. And for applications, it doesn't necessarily give you a solution because it's just databases. So what if I would like to be able to deploy any application on that cluster in this scalable fashion and flexible fashion. And that's where data ops comes in, which is short for data operations, which is kind of a, you know, a pointer to DevOps. It's not actually a term that we dreamed up. If you start looking on the internet, data ops is actually a thing. So yeah, so data ops is a feature of the SQL Server Big Data Clusters. And it allows you to automate your data app operations. So that's a kind of a general, you know, I can statement. I can automate all my data app operations. So let's look at that a little bit more deeply. So there's 2 big scenarios we're looking at: generic data applications and then machine learning oriented applications. So in data applications, generic data applications, you could want to run an application that uses a lot of the data that's inside of the cluster as close to the data as you can get, and then expose that application out to your users. So for example, let's say a master data management application that manages all that master data inside of the cluster. Why would it run on a separate server and having to flow the data through the network all the time? Doesn't make a lot of sense. So let's just deploy that application onto the cluster in some container, in a box here, in multiple containers if you want to, and allow users to consume it. That makes perfect sense, right? Okay, good. That's one scenario. The other one is you have your ETL job. You're doing Spark, you're doing SSIS. You're managing data in the cluster. You're querying over it, you're doing transformations, and what do you do at the end? Well, guess what? You write it back. Does it make sense to do that outside of the cluster? Does it make sense to query the data, keep it in memory of some machine somewhere, and then bringing it back in after you're done with it? My answer would be, no, it doesn't make a lot of sense. We're just moving data around here. So can we not just get that job-based app, like let's say a Spark package or SSIS package, and deploy it on the cluster and let it run once or on a scheduled fashion, like every day or every 5 minutes or every hour or whenever you want to? Cool, so those are the data application scenarios. And when we look at machine learning, we have some specific other scenarios, and those are the scenarios that we're using here, right, in this scenario with white world importers. So when you do machine learning, you go through a couple steps. We talked about it, but the biggest step is doing model training, right? So you have your data, the data is great, it's ready to go, it sits there ready for you to use. You do feature engineering, you develop your model. And then you need to train that model on this big set of data. Is there a problem there? Well, yeah, because the machine you work on has limited memory. So how do you bring all that data over? You bring it over in maybe a smaller file in a CSV, you filter some, but you might not be training on the actual data because you filtered some out. But just to handle it, you need to do that somehow. So what if we can just let the model train on the cluster itself where the data is? Does make perfect sense, right? The 12 petabyte you're training on sits in the cluster, so let the training happen in the cluster. So that's the other example here, model training. You can train the model on the cluster and then have it retrained there as well. I mean, when you develop your application and have it in production, retraining becomes paramount important. So you need to be able to retrain and update the model with the new data that happened to be in the cluster later, let's say every week or every month or whatever you have. That retraining makes sense to do it where the data is, because then it will be fast. Then when you have a model and it sits there, normally people wrap it into a scoring algorithm to be able to integrate it easily into an application. So again, you develop a scoring algorithm that uses the model you just trained, or your data scientist just trained. And then that scoring algorithm, it's just a piece of code. Do you want to run that piece of code inside of the business application, or would you like to get some interface in between it? And normally this is like written in Python or R or what have you, right? But your business application might not. It might not even care about it, what language you use. So we can deploy that scoring algorithm into the cluster and expose it for you as a RESTful API. That scoring algorithm uses the model that sits on the cluster to score and predict new values that it's never seen before. So you have a trained model sitting on the cluster, you have an algorithm that talks to that trained model and says, hey, now I get a new delivery instruction, let me pass it through the model and get the knowledge out of the algorithm that we developed. So now I understand where this package is going when. So all of that we do, we allow you to run that on the cluster. So basically it makes it easy to consume that scoring algorithm in an intelligent app. It's just a RESTful API that we expose. You don't need to know how that model was produced, if it's Spark or if it's R or Python or whatever, right? Or it's C# if you happen to use that for machine learning. I haven't seen a lot of people doing it, but it happens. That's fine. It's all well and good. You can do whatever you want. And you consume that in an intelligent app. And then the last step is, yeah, but wait, now I have an intelligent app that talks to the RESTful API. Just to close the loop, it might make sense to deploy that intelligent app in itself on the cluster, right? So all of those scenarios close the loop for your machine learning development and for your app development. You're training your model on the cluster because that's where the data sit. You're developing your scoring algorithm on the cluster. You're hosting it on the cluster because that's where the model sits. And then your application you can develop or deploy potentially on the cluster because, well, hey, then we have everything in one place. So that's kind of the big scenarios that we look at with data ops. So people can, of course, consume that application. So just to summarize that in one slide, it's always hard to do, but hey, we tried. So data ops is an easy way to deploy your application, scale it out because it's all containerized. So it is robust and reliable. It runs on the same platform as the SQL Server Big Data Cluster runs on. It can easily interact with all the data that's inside of the cluster, structured, semi-structured. You can use whatever language you use, whatever language you would want to use. Currently, we're limiting ourselves to these 4, which is SSIS, so running SSIS packages just as you have today, running any Python or R script, and also deploying Spark models that you created, and running them inside of this data ops scenario. And then what you get when you deploy an application on here is you get scalability, you get robustness, you get a RESTful API, you get potentially a schedule if you want to. You can run it on demand or on a schedule or both. And basically, life is good, right? It's easy to integrate into the rest of your application. So just to see how that works, creating and running an application, you would use the data ops extension, which is available for Visual Studio Code, or in Azure Data Studio, the tool that Anna just showed. It's there. It allows you to run, create that application very easily on the cluster. So you have your Python script, your R code, your machine learning model, your SSIS package. It allows you to easily create that application on the cluster. So we have that application sitting there. What you get in return is we'll give you the RESTful API. We'll automatically handle all of that for you. You get notified about that, and you can potentially schedule it if you want to. It doesn't make sense for all the scenarios, but especially for SSIS or ETL workloads, it makes a lot of sense not to use the API, but just to schedule. And then whichever you choose, RESTful API or the schedule, will consume the application in your mobile app or whatever you have, right? So that's essentially what DataOps provides you, which is an easy way of integrating those applications into your cluster. Let them run as close to the data that they use as they can be, right? They cannot be on top of the data, but they can be very close, and that's where this is. So now, in our scenario, let's think about the comment that I just made, that you don't want to send your data to the cloud, right? You will still be using Lewis, you want to use Lewis, but you need it somewhere else. So what if we take Lewis from Azure, the exact same thing that we're just showing, with the latency issues, with the security issues, with everything that we talked about, and take it in the bottom portion of the slide and host it through this app framework on the cluster. So then this Lewis thingy becomes a RESTful API on the cluster. It runs there. And since Lewis is already containerized, this is easy. The same thing you can easily bring into your own cluster, so that's essentially the demo that we have next, is that we did that. And then you can change your code to point to this local environment. So you don't need to go to the cloud because the data is security bound or it's PII information or you're not allowed to. No, you can take that application, bring it back on premise, and with minimal code changes, keep running. So I think that's time to show that, right?
Yep, let's do it. And one other point about cognitive services, for those of you who might not have worked with them a lot, is this containerization thing is pretty new. So I think they first announced containers last year, and now they've got 10 of their 22 APIs available in containers. A lot of people have given this feedback, and so that's what we're going towards. Before I show you guys what we did, I just wanted to call out this, that when we did run those 10 rows, it took about 19 seconds. So we'll see if it helps us at all to run it locally.
It should, come on, it should.
It
right?
should.
I mean, why do we do this?
Right. If it doesn't, then
just hope.
You need to go back to the drawing board. But anyway, so what we were able to do is actually deploy the cognitive services container into the big data cluster. And I went ahead and did that before this just because it takes a few minutes. But what I wanted to show you is the service that gets deployed. So I use kubectl describe service cognitive-lewis-service. So what you see is you get a bunch of information about this container that we've deployed into the service. The only thing we really have to worry about is this load balancer ingress IP. So
and the port, right?
And the port, right. Yeah, that's important. So another thing we can do from there is use curl commands, which you're probably all familiar with. But you see I'm just curling that address and the port and basically my application ID in a sample query, and I get the results. And they aren't very nice here, so I'll show it to you in the Java application. So if I switch back to this Java application, you might think, oh, well, we're going to have to do a lot in order to fix this and make it run in the container. But actually, I only have to change one line of code. So you see I've replaced calling Azure with calling that new IP address and port.
Yeah, so essentially this IP address and port is the one that you just showed.
Right, so this
right?
52.184.127 is the same as this one here.
Right, so that's the IP that you got when you deployed the app in the cluster.
Exactly, yeah. So now that this is working, I compiled this, moved it into the cluster, and we can go ahead and take a look at our results, and hopefully they're faster.
Fingers crossed.
Okay. So we basically dropped it and replaced it with our Lewis container jar, which just changes that URL we're pointing to, basically. And then we'll run the script, and hopefully internet and demo gods in our favor. It will be faster. So we see.
Look at that, 6 seconds.
You know, a good bit faster.
So what did we have before with 10 rows?
Before, I think we had, 18, 19 seconds.
Yeah, so 6, 1/3. Pretty cool.
Good savings. And that's because we're not sending each row. We're just keeping the data in the cluster and referring to it basically locally. And yeah, so let me switch back.
So just as a, any feedback on this right now? So is that something that's usable? Yep, go ahead.
Yeah, I think it's great. So like I just had a question.
Sure.
So deploying the actual big data cluster, it runs on top of Kubernetes. So does that involve Linux at all? Obviously, it has to.
Well, yeah. So the question is, how do you deploy the big data cluster? Because it runs on Kubernetes, right? So what we basically require at this point is a Kubernetes environment, which can run wherever Kubernetes runs. So one of the easiest ways, for example, to deploy this is using AKS, right? Azure Kubernetes Services. You basically set up a Kubernetes environment there, leave it empty, capture the connections, information you need about it, and then say to our tools, cluster create, and point us to that environment. And then we'll stand up the whole cluster for you.
Okay, and then the other concern I have was
Sure.
with the data integrity. So like, let's say, like disaster situation, all the pods go down or something, where's the data at now?
So the data is, I didn't talk about it in the slides, but it actually says that the configuration of the Kubernetes cluster has persistent storage. And that's actually what we're looking for here, right? So normally a container is kind of stateless, right? So it's not really usable in that fashion, but so if a container goes down, potentially all data is lost. So with persistent storage, that's not the case. So the data will be recoverable that way.
Okay.
Yeah. Sure.
I'm sorry. So
No, go ahead.
I mean, if you run it again now,
Mm-hmm.
wouldn't it be warm, and wouldn't you see even perhaps more performance gains?
We can try to run it again.
Yeah.
6 seconds is still a lot. Yeah, for a local environment. I think it's just kind of instantiated, right? So if you were to try it again.
So this takes longer than 6 seconds already. Oh, so it's now 5, 9, 6. We're improving a little bit. No, I agree with you that 6 seconds is still a lot, right? We didn't do a lot of the optimization here. We're still sending row by row. I think we're still doing 10 calls, right? What you potentially could have done in the code is, it would be a bigger code change than just one line, say, I'll batch collect all of this. And
But they keep a lag connection for 10 rows.
yeah, for example, something like that.
It's going to be less than a second.
Sure. So, but that would involve more code changes than just doing,
Oh, is it in a jar file?
It's in a jar file.
I mean, those changes should go into the jar file.
Right, exactly.
Yeah.
So the file that we have does, builds a new connection every request, right? So if I want to optimize that, I could, but I need to change more code than just one line. And here for simplicity reasons, we just chose to change one line. But yes, of course, you could improve of this. Yeah.
Like API between SQL and this code.
So what's the?
How you input and output the data? Is there any API?
So how do you, you necessarily...
So
show that?
we're still doing the in-database as you saw earlier that I showed, where we're not actually moving the data. The difference is that we're getting the data not through TDS, and that's why we're able to use a separate line of connection to get that data.
It's integrated with the query processing.
Nelly, who works on the Java extension, said it's integrated with the query processing.
So yeah, if there's no more questions, let
Other questions, comments? Do you see scenarios where this might be relevant to your business? Oh yeah, go ahead.
For on-premise, what is the responsibility? What's the separation of responsibility between what SQL 2019 manage versus what you rely on the underlying Kubernetes to manage? Can you comment on that? Because when customer purchase solution like this, they're expecting the full stack manageability
So
by Microsoft.
right.
So now with this dependency on Kubernetes or on-prem without AKS or EKS, whatever, what is the customer's responsibility?
So the question is, what is the customer's responsibility?
Kubernetes is not reliable, have issues for scaling, or who is covering what?
As far as SQL Server on-premise versus Kubernetes?
Yeah.
Also plus, the application, right? If it's running on its own pod, like the configuration, the resources, how you balance, what's the line between each of those? Kubernetes, SQL Server, plus the application pod.
Sure. So in terms of the application, you can, so the application that you run, like then we're talking about the cognitive services here, right, in this scenario. So we basically have two applications here. One that runs in Java, right, and then the cognitive service one that runs on the cluster. So for the second one, we didn't show you that, but you can actually deploy that through one command. And in that command, you can specify how many pods you want to be there, and you can have scalability as well. So you can say, you know what, I need to have minimum of, let's say, 3 pods. It can go to 6, depending on blah, 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 these environment variables, and environment situations that we have, not variables, like memory usage or CPU or whatever, right? So all of that is there. But yeah, so if any of those pods die, Kubernetes will make sure we get back up to the minimum of 3 that we specified, right? So that is kind of separate. It's all in a separate replica set. So we have one replica set for each application. So what happens inside of that replica set is for the application to decide on. Of course, you know, you could write some code that does an endless loop, and you know, makes it interesting that way. But yeah, that's kind of where we are at with those applications. So so that's that. You know, our R and Python engines that we provide here do actually handle all of that, because they came from the machine learning server that we talked about, the Revolution Analytics team. So all of that handles kind of those scenarios. And then for cognitive services, because it's a trusted application, you know, we didn't do anything else because, well, we trust our colleagues, right? They wrote good code. Just assuming that. So yeah, and then do you want to comment on the customer responsibility, Kubernetes versus SQL? Or?
You can
Okay.
comment on it.
Sure. So basically the way we think about it now is you provide us with the Kubernetes environment, and we want SQL on top of it, which means that, well, I mean, if that thing is not reliable, yeah, there's nothing we can do, right? So we expect our customers to use a good Kubernetes service or provide it.
Give a very sharp adoption gaps. Think about on-prem customers, how many have the maturity to
Sure.
production grade
Right. So
clusters?
one of the things that we're working on is helping you stand up that Kubernetes environment through sample scripts and scripts to deploy that very easily. It's proving pretty hard because there's so many configurations out there you might be willing to do, right? Different IP configurations, all that good stuff. So, but we're gonna help you there. But we're not gonna, at this point in time, we're gonna assume that somehow you come to a Kubernetes environment. And then you can deploy SQL Server Big Data Cluster. But we'll help you to come there by, you know, providing some guidance. So yeah, that's essentially where we are.
Yeah.
Just this gentleman first. Sorry. Yep.
The other question I have is also in line
Right, sure.
processes, right?
Yeah.
But versus machine learning, often we use like GPU, TPU, for this training.
Sure.
Then what will be, the possibility to put this together?
So the question is, typically data uses CPU, but if you're doing machine learning, you might want to use GPUs or even FPGAs. What's the guidance there, right?
Yep.
Um,
So to be honest, I'm not sure. I
Yeah.
haven't tested it personally. But technically, I would say, if you can make it run, if you make Kubernetes run on it, why not? But
You can label your GPU nodes.
right,
Kubernetes, you can implementize and say, I want to run
exactly.
this workload on that particular.
Yeah. So
There are possibilities to put these labels on.
so as Nelly is saying, you could have labels on the cluster saying, my machine learning workloads should be on that node. For example, GPU, FPGAs, whatever.
Specific instance type.
Yeah.
Will handle sort of both. Otherwise, you still sort of separating, right?
True. Yeah.
Only use the CPU to train the model. It may not be that efficient,
No, I mean, sure. I mean, if you go look at deep learning scenarios, then this becomes a more apparent problem, right? Yeah, I agree.
Any question over here?
No anymore?
You don't have a
That
question
gentleman
anymore?
there?
So what's the division functionality here between what's available with just regular SQL Server 2019 and the big data class?
So your question is, what is the difference in functionality between SQL Server 2019 and SQL Server 2019 big data clusters?
Yeah, I'm interested in the functionality, big data aspect.
Right.
I don't need so much Kubernetes.
So the big data clusters is really targeted to people using and interested in the big data scenario. So I would definitely look into SQL Server 2019 if you're not looking into doing the scalability with Spark and integrating that with HDFS. So the extensibility that we talked about, running the Java apps and stuff like that, is actually part of SQL Server standard, or I mean not standard because that's edition. It sounds that I'm talking about editions. What I mean is SQL Server 2019, full stop, right? And then big data clusters, SQL Server 2019 big data clusters takes that forward and says, we're going to build a cluster that has Spark and HDFS integrated. But if you're just looking for example, to the extensibility to do Java files, you can get that in SQL Server 2019 already. So parts of this, what we showed, actually runs in SQL Server 2019 big data clusters only. The extensibility also runs inside of SQL Server 2019 full stop.
What I'm curious about is what functionality that you showed is specific to BBC Notebook.
Notebooks is actually part of the ADS experience, the Azure Data Studio experience, but definitely the app deploy, so the data ops, so the pieces that allows you to deploy an application onto the cluster and get a RESTful API, right? So the SSS packages, the R and Python scripts, those things that is big data clusters only. So the thing that allowed us to take Lewis from Azure and run it on the cluster and then talk to it is BDC only, big data clusters only. The actual fact of running a jar file as part of a SQL statement, as we showed, is also available on SQL Server 2019. So you don't need big data clusters. No.
I was going to say, and when you say SQL Server 2019, that's inclusive of Azure SQL?
So when we say SQL Server 2019, we're talking specifically about Box product, the on-premises product. That being said, some of this functionality will be available in Azure SQL Database. For example, you can use the R extensibility feature in Azure SQL Database today, and we're working on Python and some of the other tools. It's a little more complicated when you move to Azure SQL Database because of the scoping. And then, for example, in Azure SQL Database Managed Instance, you can access CLR, but you can't access R at the moment. I mean, eventually we want to move towards it's the same all over the place. It's just going to take us some time to get there.
Yep.
Yep.
So how does it work from content update
You can switch.
cycles for SQL Server 2019, right?
So the question is, what's the process for basically updating for a CU pack or something like that once you move to SQL Server big data clusters? My answer to that right now is we don't have an answer to that. Right now we're working on getting big data clusters and SQL Server 2019 out the door, but I'm sure we will have a process for that.
Since SQL, right, is separate from like any REST APIs that you can stand up in the container, is it just as simple as drop SQL Server from the container and reinstall it?
Well, you have to be careful a little bit there, right? So you would have to do rolling updates over the containers. So one of the things that we're thinking about is actually doing that. So you say, hey, update, we'll take one by one. We'll go through every one of them. Yeah. JJ, you wanted to add something?
I just say from a Docker container point of view, it's a question where like you're shipping images, and you have in Kubernetes you have your persistent volumes where your data is. So it's more a question of rolling new images with the new CUs.
Yeah.
And eventually replacing all those. And then you need to be able to roll that out as well.
Is that something that you guys would be hoping to plan in place and help guide and walk people through that process?
The upgrade scenario is something that
Yep.
Yep.
I see.
So yeah, that's the plan.
Yep.
To have a upgrade experience. Yeah, sure.
What is the persistent file storage?
Sorry again.
What is the persistent file storage? What did you guys think? Is it just like ext3? Is it, what is the persistent file storage?
It's whatever you want it to be.
Yeah,
So
it's up to you.
When you're on premise and you're deploying Kubernetes, you're making the decision.
Yeah, you're saying where it is.
Local flash, and you're going to deal with that. That's
Yep.
going to be you. If you're deploying on Kubernetes in AKS, AKS has two standardized deployment models.
Yeah.
So then you can pick whether you're going to use premium storage or regular storage.
So yeah, essentially for the recording, just to wrap this up, the storage, persistent storage, you decide. And then it all depends on where you run it, right? AKS has different options than running it on premises, but you decide as a user where you want to run that persistent storage and how you want to handle that. So let's just, with 2
So we
minutes
talked
left.
about a lot of things, and I think we got some really good questions and good things for us to think about. But if you walk away remembering nothing but these 3 things, this is what we're hoping you remember. With SQL Server Big Data Clusters, we're trying to bridge that gap between your relational database deployments and your big data deployments. With the SQL extensibility framework that we're working on, you can now use more languages, and hopefully via some of the architecture we showed you, you can see how we're opening the door for other languages as well. So that's something to stay tuned for. And then third, we're giving you flexibility to run on-prem or in Azure as whatever meets your needs. There is like a pass marathon. I think it's 24 hours of pass. So if you're interested in this, Buck Woody and Bob Ward, SQL gurus, will be doing some things on SQL 2019 as well as big data clusters. So something to check out. There's one thing I wanted to show you if you are interested in this. First, you can access all of the demos from this week around data at this URL. You can access documentation around big data clusters and sign up for our early adoption program if you want access to this. And then I did want to show the SQL workshops URL because what we've done, where's my mouse?
Yeah, you're in the presentation. Yeah, there you go.
Okay, what we've done, so if you go to aka.ms/SQL workshops, we're working on deploying a lot of different resources for you. So this could be your one-stop shop. So you can see we're working on a big data clusters course. You can check that out. It's got notebooks in it, lots of information.
Sorry? No, it's currently in preview. So you can sign up for the preview if you want, the EAP, Early Adoption Program.
And then, so there's a lot of stuff in here to check out. If you,
Yeah, you can install it wherever Kubernetes runs. So yes, you can install it on premises. Yep.
And if you're interested in what we did today, if you go down to presentation materials, you'll actually be able to pick my GitHub repo. And when you go in there, you'll see the build, and I'm not sure if this is big enough, but we basically supplied you with instructions on how to set up everything we showed you today and a few other things. And then we provided you with the notebook that I showed here. And if you have any feedback or questions, or you forget something, or you have requests, where is the presentation? It went away. Please feel free to reach out to us on Twitter or wherever you can find us. I have business cards if you want one. And thank you for...
business cards?
I do have business cards. And thank you for sticking it out with us. I know it's been a long day for everyone, I'm sure, and we know it's late. So thank you, and have a good night.
Thanks.